displacement reaction. So what is displacement? It is third type of chemical reaction. The reaction in which a more reactive element displaces a less reactive element from its compound are called displacement reactions. So here we'll come to know that always a high reactive element displaces the low reactive element. For example, here we are showing some metals here in our order wise, decreasing order wise. So potassium is a high reactive than the sodium, sodium is high reactive than the calcium, calcium is high reactive than the magnesium, and so on. Last platinum is the metal which is least reactive, means the reactivity decreases from potassium to platinum. Potassium the symbol K because it is kalium. So from potassium to platinum the reactivity decreases, that's why I told you downward arrow mark. So from this what will conclude, any lower reactive metal when they react with a high reactive compound it may not displace that. For example, if you take MgCl2 magnesium chloride plus sodium, this magnesium can displace the sodium easily. How we can come to know that? So magnesium is a least reactive element, sodium is high reactive element. Sodium is capable of displace the magnesium. This magnesium has to displace from its chloride, means sodium has capacity to remove the magnesium from the chlorine, means this reaction takes place and it forms NaCl plus Mg, means magnesium is the least reactive than the sodium, so easily it will displace. But if it is reverse, means NaCl plus Mg, this reaction will not possible. Or else if you take any other one more example, aluminum chloride AlCl3 plus zinc. Is it possible? The reaction is possible or not? No, this reaction is not possible. Why? Because zinc is a low reactive metal than the aluminum. Zinc does not have capacity to displace the aluminum. Zinc will not displace the aluminum because zinc is here, aluminum is here. Aluminum is high reactive than the zinc. So we are going to discuss about the reactivity series. All elements, whether the reaction is possible or not, based on the reactivity series, we will come to know that. And there is some method of balancing the even writing the chemical equations by using the reactivity series. Potassium, sodium, calcium, magnesium, these all are high. Even aluminum also high reactive elements, it comes under high reactive elements. Zinc, iron, lead, hydrogen, copper, so these are comes under moderately reactive elements, medium reactive elements. And even copper comes under both moderately and least reactive elements. Copper, mercury, silver, gold and platinum, as these elements have a least reactive elements, as it doesn't react with more elements. So these are considered as least reactive elements. So about these metals reactivity series I will study in the third chapter, that is metals, non-metals. Okay, next concept, that is we learn about the displacement reaction. What are displacement reaction? We'll come to know in this. Okay, let's watch the video to understand the displacement reaction. Displacement reaction are of two types, single displacement and double displacement. Take 3 iron nails and rub the iron nails cleanly. So take 2 test tubes separately, A and B. Add 2 iron nails in a test tube B and immerse that in a solution which contains copper, means copper sulfate solution. And after 20 minutes, after immersing the iron nails in a test tube B, we will observe that the solution of test tube B changes to light color, and the iron nail has got a green color. This is nothing but the copper sulfate color faded, means iron has displaced the copper from their salt solution, means iron has removed the copper. Copper is the least reactive element. If you check the reactivity series, you will come to know that, whereas copper least reactive, and iron is high reactive element, iron is top. So it can easily, iron can easily remove the copper and it forms as iron sulfate and copper deposited easily. So next, double displacement reaction. What is double displacement reaction? The reactions in which two different atoms or group of atoms are exchanged are called double displacement reactions. One more definition for this is, or we can say that the reactions in which two ionic compounds in the solution react by exchange of their ions to form new compounds are called double displacement reaction. See, in a previous video only we saw that iron displaces the copper from their salt solution, Fe plus CuSO4. So where iron is a high reactive element, it has displaced the copper and it forms iron sulfate and copper deposited, FeSO4 plus copper is deposited. But in double displacement reaction, single displacement reaction, one is element and one is compound, but double displacement reaction both are compounds. For example, magnesium chloride plus sodium sulfate, Na2SO4. So when they react with both, it forms magnesium sulfate sodium chloride, MgCl2 plus, I will write here MgCl2 plus sodium chloride. So this is a product which are obtained by that method. Means the magnesium is a plus cation and chlorine is an anion, sodium is a cation and sulfate is an anion. When they react with each, both exchanges their ions, positive and negative. See here, iron is a positive, copper plus cations and sulfate anions. I told you about the in previous class, then which are the anions, which are the cations. The elements which donate the electrons are called cations, the elements which receive the electrons are called anions. So in this, any compound in double displacement reaction, actually the two compounds are the contains cations and anions equally. So just they will exchange their ions itself. But in single displacement reaction, only one is element, another is compound. But in double displacement, both are compounds only. There is no element at all. So next, we'll see the video how double displacement reactions occurs. Okay, we'll see the video to understand the double displacement reaction. So let's watch the video to understand double displacement reaction. We are taking two test tubes which contain lead nitrate solution and potassium iodide. Lead nitrate is PbNO3 taken twice and potassium iodide Ki. So if we add a potassium iodide in a lead nitrate solution, the color of the solution changes to yellow color and it forms a precipitate, yellow color precipitate, that is potassium iodide it forms, iodide, potassium nitrate reacts with the iodide, potassium iodide, lead nitrate reacts with the potassium iodide, it forms lead iodide and potassium nitrate. So this lead iodide is precipitation, it forms a precipitation, and even we will call this as precipitation reaction also. Next we'll see that precipitation reaction. It is also a type of double displacement reaction only. The reactions in which aqueous solution of two compounds on mixing react to form insoluble compound which separates out as a solid, called precipitate. Such reactions are called precipitation. See, in previous class, previous video, we saw that lead nitrate PbNO3, I will show once, PbNO3 taken twice reacts with the potassium iodide. Here we got yellow PPT of lead iodide PbI2 plus potassium nitrate KNO3. So this PbI2 is called a precipitation, precipitate. It forms a precipitate, means a downward arrow mark. It insoluble. It was insoluble in a test tube. That insoluble precipitate in compound will call as a precipitate, and such the compounds which forms this type of reaction will call as precipitation reaction. So let's watch the video to understand about the precipitation reaction clearly. So let's watch the video to understand the precipitation reaction. So in this we are going to take two solutions, both are aqueous solutions of sodium sulfate and barium chloride. When you add the barium chloride in sodium sulfate, it forms a white precipitate, nothing but barium sulfate. This white precipitate is barium sulfate, and the equation is as follows: barium chloride plus sodium sulfate will get barium sulfate as a precipitate, and sodium chloride will get aqueous, and is solid. Yes, barium sulfate is solid because it is a precipitate. I think understand this precipitation reaction. So today is enough for this session. Next class we'll see about some more chemical reactions. Thank you.